Hello, it's Mr. LaBeouf here with the second video intended for fifth graders to take us upon a journey to understand the multiplication of fractions. But before we get deep into the topic, before we get down into the weeds of fraction multiplication, let me set your mind at ease a little bit. Explaining why fraction multiplication works the way it does takes a little time. But the how is very simple. It's a great irony. It's very easy to multiply two fractions. For example, 3/7 times 8/10 is 24/70. 3 times 8 is 24, 7 times 10 is 70. Of course, that simplifies. The 8/10 could have simplified to 4/5 to start with, but this is my only point here is that you simply multiply across the top and bottom. You do not need a common denominator. Please don't try to get a common denominator when you're multiplying fractions. It's a waste of time, and you're more likely to make a mistake, so please don't do it. Perhaps one of the greatest challenges at any level of math is to distinguish among different things you're asked to do, different operations, for example. Adding and subtracting fractions is completely different from multiplying them. And by the way, you might ask about the fourth operation of division. Once we are comfortable with multiplication, dividing fractions will be very simple. We will look to the definition of division. What does it mean to divide? And then it will be pretty obvious why the way we divide for fractions works the way it does. But let's focus on the multiplication. And we can put what I just said about the ease of multiplying two fractions into symbols. We multiply two fractions by multiplying across the top and bottom. So if we have a over b times c over d, two arbitrary fractions. The only restriction here is that the b and the d cannot be 0. We can never have 0 in the denominator. I may or may not have explained why that's true to you, but you will at some point know why. You can never have 0 in the denominator of a fraction. Anyway, with that said, look how easy it is. Of course, you know by now that this means A times C. AC is A times C, and BD is B times D. So A over B times C over D is AC over BD. Just multiply across the top and bottom. What could be easier? But let's understand. That's our task, to understand why it works. In our first exploration of the multiplication of fractions, we focused on finding a fraction of a whole number where the product or the answer is itself a whole number. And that works, it comes out that way, when the denominator of the fraction is a factor of the whole number. 3 is a factor of 15, so that causes the question, what is 2/3 of 15, to come out to be a whole number, and the answer is 10. The way we understood this before was we think of the 2/3 as 2 times 1/3. We associate the word of with multiplication so that 2/3 of 15 is the same as 2/3 times 15. So let's continue to keep that in mind. Of and times, same thing. 1/3 of 15 is 5, so 2/3 of 15 is twice as much as 5. 2/3 is twice as much as 1/3, so if 1/3 of 15 is 5, then 2/3 of 15 is 2 times 5, or 10. Now, why is 1/3 of 15 5? Because the denominator of the fraction serves the function of division. We're multiplying here, but the denominator of the fraction has a division type of effect on the numbers. So if we have a number line from 0 to 15, and we're talking about 2/3 of 15, we need to divide that distance from 0 to 15 into 3 equally sized pieces because of the denominator of 3. And when we do that, we clearly see that the divisions would be 5, 10, and then 15. And if we're interested in the second third, or 2/3 of 15, then of course it'll be that 10 right there. Let's now, however, use the formula of multiplying across the top and bottom. Let's go to the top up here with 2/3 times 15. Well, the 15 doesn't look like a fraction right now. It actually is a fraction. How can you make any whole number look like a fraction? Put a 1 under it. You could actually say that 15 is 30 halves, or 45 thirds, or 60 fourths. There are an infinite number of ways of representing any number. The easiest way to make 15 look like a fraction is to put a 1 under it. 15 over 1, 15 divided by 1, 15 ones is 15. We multiply across the top and bottom. Watch what happens here. 2 times 15 is 30. 3 times 1 is 3. So we get an answer of 30 over 3. 30 divided by 3. 30 thirds. Either way you look at it, it's 10. So we're making a little progress. Now we need to consider a different problem. I think that most people, even young students before they ever reach me in 5th grade, have an intuitive understanding, a gut level understanding of the question of what is half of a half. And think about it. Isn't it a fourth? A half of a half is a fourth. Maybe the intuitive understanding of that might involve thinking about something like a pizza. And you bring a knife, or a cake or a pie, you bring a knife down through the center of the circle, and you've created 2 halves. And if you were to eat this part of the pizza or the pie just over here, that would be 1 half. But what if you take the knife again and you cut that half, one of those halves, in half again? Now, one of those pieces, it's half of a half, but it's also a fourth of the original circle. And if you go over like that, you can clearly see that that piece there is 1/4 of the entire circle. It's also half of that half. That, I think, is the basis of the intuitive understanding. Let's replace the word of with the times sign, as we can always do. Half of a half is a fourth, but if we write it like this, and we multiply across the top and bottom. Now, there happens to be a common denominator here, but you don't need that. A half times a half is 1 times 1 is 1, and 2 times 2 is 4. So there it is again. What about on a number line? A number line is a more sophisticated, better way to understand the operation of fractions than a pizza or a pie. This is very limited. We can look at half of a half, but if we get to 17ths or fractions like that are what I like to call ugly fractions, maybe that have a denominator of 17 or a denominator of 31 or something like that, thinking about how a pizza or a pie might work is not going to really help us. So the number line is crucial. There's a simple halves number line between 0 and 1. And if we now look at this portion here of the number line, and we want to take half of it, we would put a point here, creating 2 equally sized pieces. And people just kind of know that that's a fourth, right? And over here would be 3/4. You kind of know that, but why is it a fourth? Well, the 1/2 is 2/4. 1/2 is 2/4. So just think now, half of 2/4. Just like half of 2 cookies, half of 2 of anything. is 1 of that thing. So half of 2/4 is 1/4. Okay? And I think that's about it for half of a half. I think we've explored that enough. All right, but do you see how we can think of it as half of 2/4? And that numerator being 2, half of 2 is 1. So half of 2/4 is simply 1/4. All right. How about half of 1/3? Maybe it's just not quite as intuitive. If I were to ask a young student what half of a third is, a student that, say, 3rd grade or something like that, it's very likely that a young student like that who could answer half of a half as a fourth may not be able to answer the question, what's half of a third? Well, using the formula, of course, 1 times 1 is 1 and 2 times 3 is 6. Half of a third is a sixth. And when talking about thirds, it's sometimes nice to look at something that looks like the Mercedes-Benz hood ornament, or as some people are aware, back when I was young, it was popular you would see a symbol like this, which meant a peace sign. It meant peace. Sometimes it would have a line going down here. I don't really know the origin of that symbol, but this diagram right here, again, it's kind of thinking about a pizza or a pie. Each of those pieces is supposed to be 3 equally sized pieces, so one of them is a third. And if you take half of one of them, like I just had up here, that piece right there, that's a sixth of the entire circle. Because if I did that like that 2 more times, now that one piece is 1 out of 6 pieces of the pie. It's half of the original third that I showed you, but it's also 1/6. On the number line, there's 0, there's 1. 1/3 would be about there. 2/3 would be about there. And if we're interested in what is half of 1/3, it would be this point. Now, again, a lot of young people who know that half of a half is a fourth, they may not be able to look at this number line and say that that's 1/6. But how about this? How about if we think of the 1/3 as 2/6? You know that 1/3 is 2/6, right? So then you ask the question, what is half of 2/6? It's 1/6. This point right here is 1/6. Okay? If we could continue, of course, to make this thing entirely a sixth number line, 1/6, 2/6, 3/6, which is a half, of course. That's supposed to be halfway. And then the 2/3 would be 4/6, then 5/6, and then the 1, of course, would be 6/6. Half of 1/3 is 1/6. Multiply across the top and bottom. Let's ask this question. What is 2/3 of 15/17? Now, this one here is a slight progression forward, but there's something about it that makes it easy to deal with. The 15 here, this numerator, and this denominator here of 3. 3 is a factor of 15. We're going to actually, in a moment, we're going to recall the earlier problem of 2/3 of 15. That's going to help us with this. But let's first take the approach of, let's get an answer. Let's get an answer as easy as possible without putting much thought into it, And I always want math students to think about math deeply when it's necessary. But at some point, after you've understood something very well in math, another goal should be to make it automatic. Because you can't reinvent the wheel every day. You can't go back to the very beginning every day. You have to understand something very well and then make it automatic. When you were younger, you might have thought about, spent a fair amount of time thinking about why is 7 times 963. And there are a number of ways you can do that. You can count 7 nines, 9, 18, 27, and so on, until you get up to 63. Realize that it takes 7 nines added together to get to 63. You could, you might have even thought, well, 7 times 10 is 70. 7 times 9 is going to be 7 less than that, because, 10 times 7 is 70. 9 times 7 is 1 fewer 7. So it's 7 less than the 70, and it's 63. And that's wonderful to be able to think that way. But if you're in the middle of multiplying a 3-digit number by a 3-digit number, and you happen to have to do 9 times 7, you don't want to have to go back and think about all this. So you make it automatic that 9 times 7 is 63. And with this fraction multiplication, you're going to be doing that as well. But at this point, the understanding is kind of fun. To be able to do something, even if it's automatic, but to be able to do something not because I or a textbook or somebody told you to, but because you believe it. You believe that it makes sense. That'll make math much more enjoyable, and you'll be better at it in the long run as well. So the automatic nature of this problem, 2/3 of 15/17, would be simply, the answer is 30 over 51. Now, as it turns out, that wouldn't be what I call the final preferred form. That's part of this little lesson about this problem. We'll see in a moment. But it's a correct answer. 30 over 51. 2 times 15 is 30, and 3 times 17 is 51. That's not a multiplication fact that anyone's expected to learn, but use the distributive property. 3 times 10 is 30. 3 times 7 is 21. 30 and 21 make 51. So that's the answer. And we could say case closed and move on. But let's now think about this problem in a way that relies on what we did earlier. And as I said a moment ago, this 15 here in the numerator, the 3 down here, the denominator, is a factor of 15. So remember earlier we did 2/3 of 15? Remember that? 2/3 of the whole number 15 is 10. So think about this for a moment. What is 2/3 of $15? $10. What is 2/3 of 15 people? 10 people. What is 2/3 of 15 pencils? 10 pencils. I think you're ready for this now. What is 2/3 of 15/17? 10/17. Doesn't that make sense? Okay. Now we might have a little issue here with the fact that we seem to have 2 different answers, but we really don't have 2 different answers, do we? Because that 30 over 51 is a fraction that can be simplified. The 30 and the 51 each have a common factor higher than 1. They have a common factor of 3. We can divide the top and bottom of the 30 over 51 by 3. 30 divided by 3 is 10. 51 divided by 3 is 17. So we did not get 2 different answers. Let's look at a number line. And just like any other case where we're finding 2/3 of a number, we're going to divide the number into 3 equally sized pieces and look at the second one. This number line should look pretty good for its purposes because I just used a yardstick and made a line segment that was 17 inches long. And so at the end here, I'm going to call the end point over here 1. It's a number line from 0 to 1, but 1 is also 17/17. And then I put a little point at 15 inches, so that what we're looking at, what we're concerned with, is not the entire length from 0 to 1, but just from 0 to 15/17. Okay? So just focus on that piece of it. And if that point there is 15/17, if I divide the distance between 0 and 15/17 into 3 equally sized pieces with these 2 points, 1, 2, 3. This length here is the same as this length, which is the same as this length. I have divided the distance between 0 and 15/17 into 3 equally sized pieces. Well, what are the names of these points? Well, this, of course, is 5/17, and with the ruler, that was 5 inches. Right? And this point here is 10/17. That's the answer. We've divided 15/17 into 3 equally sized pieces, and then we go to the second one, which is always how fractions work. So there you go. All right, here's where it gets interesting. 2/3 of 5/7. 2/3 of 5/7. Well, look what I wrote up above. It's equivalent to 2/3 times 5/7. So we know the answer. It's quite simple, right? Multiply across the top and bottom. Easy. But let's understand why. I've constructed a number line once again from 0 to 1. That's not 7 inches. It's actually 14 inches. I wanted to have enough size, so I made it 14 inches. But I considered this to be 1. It's 7 sevenths here. The 5/7 I put at 10 inches, right? Because the whole thing is 14. So yeah, that's how I did it. Anyway, it should look good because I measured. So we are interested in that line segment from 0 to 5/7. Like that. And we want to know where 2/3 of it is. We want to divide this length into 3 equally sized pieces. But how do we do that when it's 5/7? You see, the issue here now is this 3 is not a factor of 5. 5 divided by 3 is not a whole number. So what do? Well, here's the answer. We use the most important fundamental concept of middle school math, and that is the equivalent fraction. If you multiply the top and bottom of a fraction by the same number, you get an equal number, an equivalent fraction. Or if you divide the top and bottom of a fraction by the same number, you get an equivalent fraction. It's hard to know what 2/3 of 5/7 is or 1/3 of 5/7. First, we have to know what 1/3 of 5/7 is, and then multiply it by 2. But what is 1/3 of 5/7? How about this? What's 1/3 of 15/21? You can answer that question, right? Well, why did I do that though? Notice, how did I go from the 5/7 to the 15/21? I multiplied the top and bottom by 3. Why did I multiply it by 3? Because we have a denominator of 3 here. That will make it come out nicely. So we go times 3 and times 3 to get 15/21. Okay, you tell me what is 1/3 of 15/21? What is 1/3 of $15? What is 1/3 of 15 people? It's 5, right? So $5 or 5 people. So 1/3 of 15/21 is 5/21. I'm going to eyeball these points I have to put here. We're talking about 2/3 of 5/7. So here's the 5/7, this length here. I'm just going to eyeball the 2 points that I have to put. I think it's going to look something like that. Does that look good? Like I've divided that length into 3 equally sized pieces. 1, 2, and 3. That's pretty good for eyeballing it, right? Well, the 5/7 is 15 21st, so 1/3 of that length will be 5 21sts, and then the second third will be twice that, double that, to get 10 21sts. And there you go. There it is, right there. The same answer that we got when we multiplied across the top and bottom. This, for 10-year-old students, 11-year-old students perhaps, this is kind of sophisticated. It's a little bit subtle, but if you watch this carefully, maybe more than once, I think you'll find it very rewarding that in the future, when you just go ahead and get the right answer by multiplying across the top and bottom, you can have confidence in it because you have thought about what it means. And just like when you use 9 times 7 is 63, you can use it with confidence because you've thought about the why behind it. I thought maybe one more. I almost closed it off just there. You might have noticed I was kind of sounding like I was finishing up, but I want to do one more because we've not yet today, I think in the first video we explored this somewhat, but we haven't looked at the idea of multiplying by a fraction greater than 1. This 4/3 here is greater than 1. So how about this? Let's start with that. If you multiply a number like 21/45 by something greater than 1, you're going to get a number that's greater than the 21/45, right? Or, think of it this way, 3/3 of something is the whole number. 3/3 of 21/45 is 21/45, so 4/3 of it has to be bigger. Can you figure out mentally what 4/3 of 21/45 is? Now notice we're back to this situation. This 3 is a factor of the 21. It's easy to think of what 1/3 of 21/45 is. What's 1/3 of $21? $7. What's 1/3 of 21 people? 7 people. What's 1/3 of 21 apples? 7 apples. What's 1/3 of 21/45? 7/45. So let's think of it this way. 4 times 1/3 of 21/45, right? The 4/3 is 4 times 1/3. 4/3 is 4 times bigger than 1/3. We can ask what 1/3 of 21/45 is first. We can do that part first. This is the associative property of multiplication. We don't have to do the 4 times a third first. We can answer this question first. And of course, 1/3 of 21/45 is 7/45. But if we're interested in 4/3 of 21/45, we have to multiply that 7/45 by 4 to get 28/45. Okay, pretty easy. We could show that on a number line, but I think we will close it off now. We're approaching 30 minutes. I just wanted to make the point that you don't have to have two fractions that are both less than 1. You could have one or both of the fractions be any kind of fraction, greater than 1, greater than 2, greater than 100. It'll work the same way. So I hope this has been enjoyable and informative. It's not the end of the journey. We will continue to talk more about the multiplication of fractions, but we've made progress from the first video, and you should have a sense that it's very easy to multiply fractions too because of that formula. Let's not forget about that. You know, students often like to get correct answers on math quizzes and tests. I know that's something that students like to do. You should want to do that, of course, but look how easy it is. A over B times C over D is AC over BD. As you go forward in your math lives, you're going to do that many times, and hopefully you will have confidence in it. You will believe that it makes sense. In addition to getting the right answer, you'll believe in it. That's great. So, it's been a pleasure. Enjoy the rest of your weekend. Ms. LaBeouf saying goodbye for now.